we're going to use an apparently very simple but very powerful algorithm that operates in the time domain that's called time domain pitch synchronous overlap and add, which for obvious reasons we prefer to call PSOLA. And we're going to use it to change the fundamental frequency of this word.
Suit.
As you can tell from the name, the algorithm is pitch synchronous, and that means we need to mark the pitch periods in the speech. And since we're doing this the hard way, we're going to do that by hand. So first we need to find the voice region of speech. Let's just zoom in a little bit. And we're going to mark each of the main peaks within these pitch periods. That's completed. So here we have a pitch mark on every pitch period. Now that we've pitch marked the speech, we're going to divide the waveform into individual pitch periods. And conceptually, we're going to cut out single pitch periods like this, and then we're going to manipulate the speech by moving the pitch periods closer together or further apart. The individual pitch periods are not going to be modified. That's because they're the impulse response of the vocal tract and contain the information about the formants and the vocal tract shape, and we do not want to change that. To decrease the fundamental frequency, we increase the pitch period and just move the pitch periods further apart. To increase the fundamental frequency, we're going to move them slightly closer together, and in that case they'll overlap, and where they overlap we'll just add them together to smooth out the join. Now in practice we actually work with units of 2 pitch periods, and we're going to window them so that when we move them further apart we don't actually have gaps between them. So let's cut out lots of 2 pitch period units. Here's the first one. Here's the second one. And I'm just going to repeat that for the whole voice region. So that's completed. I've put each of the pitch periods on a separate track here. And the unvoiced regions I've just left untouched for this exercise. That's the beginnings and the ends of this word. The next step then is to apply a tapered window to each of these pitch periods to make the overlap and add process work. We're just going to do that in a very simple way here. We'll just add a fade in and a fade out at the beginning and the end of each of these pitch periods. It's a very simple triangular window. So to the beginning, just make it fade in, and to the end, we'll just make it fade out. So we see now that the pitch period tapers away to 0 amplitude at the edges of this window, and we'll do that to every pitch period. So there we are, each of these pitch periods now has a tapered window, so it fades away to 0 at the edges. I've done that to every single one of the pitch periods. So what we've done is decompose this original waveform into a sequence of pitch periods which overlap and add together and effectively reconstruct the original signal. So let's get rid of the original signal and listen to the sum of these overlap and added pitch periods.
Suit. Suit.
So let's increase the fundamental frequency, just move all the pitch periods a little bit closer together, and where they overlap we'll just add them together. So I'm just going to move all the pitch periods a little bit closer together, something like this. So that's done. I've moved all the pitch periods a little bit closer together. So we're done. Let's just remind ourselves what the original sounded like, paying attention to the pitch.
Suit. Suit.
And let's listen to the overlapped and added pitch periods that we move slightly closer together. So I'll mute that. And indeed, it does have a higher pitch. Now, there's some artifacts there because we did this in a very naive and simplistic way. But with a high-quality automatic implementation, PSOLA can give very transparent changes in the fundamental frequency and also in the duration.